The XY text illustrating device. It is able to route keyboard input to an XY plotter fitted with a writing utensil such as a pen or a pencil. The system provides the user with a wide variety of tools that combine the personalization of handwriting with the precision of a printer. It is able to write in many different sizes of font. In addition, it is able to enter draw mode, which produces drawings based on the arrow keys of the keyboard. Finally, the system has several preset drawing functions, such as game boards. The invention can be broken up into three parts. The first part is the XY plotter. The plotter consists of two stepper motors that are connected to belts, as well as two sliding decks that allow for full range of movement. One slider is able to move along the XY axis, while the other slider moves along the Y axis, creating a two-dimensional operating zone. The next part of the invention is the electronic hardware. The hardware consists of two stepper motors connected to stepper motor drivers to allow for easy communication between the motor and a SmartFusion FPGA. Other hardware components include a standard keyboard routed through a Raspberry Pi and an LCD display directly connected to the SmartFusion.
As was said, we used two stepper motors, a Raspberry Pi, and a SmartFusion board to control the XY plotter. The Raspberry Pi listens to the keyboard and collects the inputted characters and symbols, piping the raw data to the SmartFusion for processing. Any general computer keyboard will work. However, we found that the Dell keyboard with numeric keypad works well. The collected raw data is then bussed into the SmartFusion portion of the FPGA logic board for data processing and transmission into the FPGA's logic block. The FPGA will interpret the data that is received from the input component and transmit instructions to the various other outputting components to construct the inputted character onto either the LCD display or as text on the sheet of paper. The FPGA will instruct the stepper motors to move the pen across the sheet of paper, simulating an XY plane, in a pattern that is to resemble the inputted character. The Z solenoid is used to control whether the writing tool is in contact with the paper or not by receiving either a high or low voltage from the FPGA. All these boards are connected using a variety of different serial outputs and inputs. For the Raspberry Pi, we used a UART communication. For the SmartFusion, we used GPIO out to the stepper motors.
I will now demonstrate the functionality that we have included in our device. Firstly, I will show the letter printing ability. This was the A, the B, and the C. It only supports capital letters in this iteration of the design. Here is the Q, the R, and the S. It also has another ability, the tic-tac-toe ability. So if you press Ctrl T, it will automatically draw a tic-tac-toe board. And two people can now play together a game of tic-tac-toe using the number pad on the keyboard. Number pad 7, for example, will draw in the upper left square, and number pad 5 will draw in the center square. It automatically alternates X's and O's, so there's no possibility of cheating. The third ability it has is its ability to do free draw. By pressing Ctrl D, you will enter the free draw mode, where the pen can now be controlled with the arrow keys. Arrow key down moves the pen down, left moves the pen to the left, and so on, just as you might expect. You can also lift the pen using the space bar, which will allow you to move around without drawing on the paper. To get out of free draw, you press the Q button, and it will now automatically go back to the letter drawing mode. And finally, you can increase the font size using the plus and minus buttons on the numpad. This is the standard font size. This is a slightly larger font size. And this is a larger font size still. You We can also make it smaller. It even has a really small size. Where the letters are barely unrecognizable.